Hey, Mr. Wilson here. Today we're looking at halogen displacement reactions. A displacement reaction is when a more reactive halogen displaces a less reactive halide ion from a compound to produce a different halide compound and a different halogen. An example is chlorine displaces iodide from potassium iodide, making potassium chloride a different halide salt and iodine as an element. Here is the symbol equation for that reaction. What's happening to the electrons is that the iodide ion has an extra valence electron, giving it a full outer shell and a negative charge. This electron is transferred to a chlorine atom, so we make a chloride anion with now the full valence shell and the extra electron which gives it the negative charge, and an iodine atom. The iodine atom would bond covalently to another iodine atom to make an iodine molecule, I2. And similarly, the chlorine atom would come from a covalently bonded Cl2 chlorine molecule. A hazard in this practical is that we use solutions in water of the halogens. Bromine in particular is harmful to human health. The risk is that the bromine could be ingested into your body. Precautions to stop this happen are wearing safety specs and being careful when handling the halogens. If any gets on your hand, you straight away need to go and wash your hands. I'm now going to show you what this reaction looks like. Here I have a spotting tile. The first thing we're going to do is on this tile, we're going to write iodide, I minus here. We're going to write bromide, Br minus here. And we're going to write chloride, Cl minus here. And then down the sides, I'm going to put I2 for iodine, Br2 for bromine, and Cl2 for chlorine. These labels here along the top correspond to columns. These correspond to rows. I have 3 halide salts. For example, I have potassium bromide. I also have potassium iodide and potassium chloride. The next step is that I take a pipette and I'm going to put 3 drops. This is potassium iodide, 1, 2, 3, 1, 2, 3, 1, 2, 3 in all of those spots for halides, for the iodide. Next, I'm going to take the bromide. And again, put 3 spots. 1, 2, 3, 1, 2, 3, 1, 2, 3 in all of my bromide bits. And finally, I'm going to take my potassium chloride and put 3 drops in each of my chloride spots. 1, 2, 3, 1, 2, 3, and 1, 2, 3. Now my iodide salts are ready to add some halogen solutions to them. I'm going to start off with iodine. So I'm going to go along the row and add 1, 2, 3 drops of iodine to the first spot. 1, 2, 3 to the second. 1, 2, 3 to the third. And I found it quite difficult there, so you have to be very careful to get those spots exactly the right amount, not too many. I can't see a colour change happening there, so that it doesn't appear that the iodine has been able to displace any of the halide ions. Next, I'm going to do the same with bromine. I'm going to put 1, 2, 3 spots on the iodide. 1, 2, 3 on the bromide. 1, 2, 3 on the chloride. This time, I can see a slight colour change where I've added bromine to the iodide. This is because the bromine is more reactive, so we know that it will displace the iodide. Finally, I'm going to add chlorine to 3 of the spots. Here we go, chlorine, 1, 2, 3 spots to the iodide. 1, 2, 3 spots to the bromide. And 1, 2, 3 spots to the chloride. What we can see has happened here is that the chloride has caused a colour change here. So the chlorine has displaced the iodide, The chlorine has caused a colour change here, so it's displaced the bromide. The chlorine has not displaced itself, the chloride. To summarise, I've got 3 different halide solutions and 3 different halogen solutions. When I've mixed the two, I have found that some of the halogens are able to displace some of the halides, but others are not. This all depends on their reactivity.